So hello, I would like to welcome everybody back on my channel. Today I would like to talk about vertical farming. In particular, I would like to talk about what I call them alternative systems. What does it mean? It means that they are not built in the conservative way that you have one layer above the other, and I would like to find out whether they can be considered as scam or if they are maybe useful. Okay, here we go. So first I would like to introduce you to some what I call them alternative systems in vertical farming. I show you them as screenshots, so you have the URL here that you of course have to source to the picture. And that one here is from Dyson. Dyson is the company that also produces the vacuumers. And I read parts of an interview that the CEO he's a billionaire and now he wants to produce also crops for whatever reason. I have not completely read the interview, but it doesn't matter. We just want to talk about the systems. So let's analyze this a little bit, what the basic idea is. So you can see that, of course, here on top in this greenhouse, we get light from the sun. Yeah. In addition, they installed LED lights here. I make the light hitting the plants in a different color, that we have a little bit of a better overview. So they installed lights on top, and within that tube you have some more lights at the bottom. You can see them here. Because I assume when you cross half of the tube, a lot of the light that comes from the top, a lot of light that comes from the top is simply blocked. So the idea is to build a circulating tube with lights at the bottom and some additional lights on top, plus of course the sunlight. So that's the basic idea. Okay, that's the second one I would like to show you. You have the URL here on top again. So let's analyze this a little bit. You have a metal frame here, and you see we have some kind of chambers here. The plants are put in small holes. The roots are bare, and this is built a little bit like an assembly line, and you see that the basic idea is that they load the system here, and you see all these plants here. They are more mature than these plants. So here you put the young plants, and here you can harvest the older plants. So that's the basic idea. So this is the third example. You have the URL on top again. And what do they build? They have again here tubes. I don't know how long they are. And you have some central LED, and you have the plants growing around. I don't know if that is circulating. I didn't read it. I just wanted to show you the pictures that you understand what I consider a alternative system. Um, to make this complete, I would like to show you a regular vertical farming system in which we scale up on the vertical axis. This is why we call it vertical farming. We have 1, 2, 3 layers, or I call them single compartments in this example. You can see here we have these yellow drawings. They are supposed to be LED lights over plants, and we have these 3 layers, and these 3 layers, you can see the orange arrow shows the extent of 1 layer, and the total scale is these 3 layers or single compartments times 3 makes our total scale. You can ignore these ones here, the feet, you can ignore them. I just wanted to show you that our regular system is built of single compartments and that when we sum them up, we have the total scale of our system. So in order to understand or to analyze whether these alternative systems, whether they're useful, whether they're good, in order to analyze their system architecture, we need to analyze about their efficiency, because efficiency means that we put some resources in these systems and we need to see what we get in return. And when we talk about plant production, we always talk about yield. So we need to link the architecture in a comparable way for all systems we can imagine and yield. But first, we need to understand how we measure the yield. Because normally, when you just think of a field or of a greenhouse, we have one error. You see that example here with crops. And then we have yield per error. For example, kilogram per square meters. With an example for wheat, we have, for example, 80,000 kilograms on 10,000 square meters, which makes 8 metric tons per hectare. This is how we normally measure our yield and the efficiency of a system. Because, for example, with wheat, let's say we don't have so much rain, this could go down to 5 metric tons. Or this is a very sandy soil, then this could also go down to 5 metric tons, and then the efficiency of that area, we can say it is not so high because in that region we don't have enough rain, or in that region we only have sandy soils and then they cannot hold the water. This is why we don't have such high yields, and this is why these areas or these regions where you cultivate, they're not as efficient as other areas where you cultivate. This is the point. We always need to find out how efficient is a single system. Okay, then let's go back to our example where we have our 3-layer vertical farming system with a regular structure, with a regular architecture. And how can we measure the efficiency of the system? Let's say we cultivate, for example, we cultivate lettuce on each of these layers, all the same plants, and each of these layers has 1 square meter. So the total scale, it will be 3 square meters. We have 3 square meters on which we produce. And for example, let's say you have 2 exact same systems. That one here, it has, you see, I have drawn this in yellow, and let's say this has full spectrum LEDs. And the other system, it is built exactly the same, another vertical farming regular system with 3 layers and 3 square meters each, and it has red and blue, and it would look like this, for example. I just didn't copy it because then our board here would get a little bit too full, but I think you can follow me. And then you can compare these 3 square meters of, first we have full versus red and blue, okay? And then you compare your yield, just make a Y here, In full we have, for example, 20 kilogram of lattice, and with red blue we reach 25. Okay, let's say each layer has 100 watts. Okay, 100 watts full and 100 watt red and blue. So the red and blue in this example is better. Okay, you know, the problem is that here we compare 3 square meters of it's the exact same type of build. But what if we have two systems with, let's erase this. What if we have our first system, like where we have only these full spectrum LEDs, and that one, it has like 100 watt of full, and then we have a complete different system. A complete different system that has a mixture of red and blue plus full plus far red, and you have per square meter 95 watts, but each layer is only 0.7 square meters, but you have 4 of them, you know, but the height is a little bit different. The height is not, let's say we have here, for example, let's say this was 40 centimeters in our regular system, and here we only have 30, but it's still enough for the lattice. I think you understand my point that these systems, no matter whether they are built with full spectrum 100 watt LED or 95 watt LED, with whatever spectrum, they can be different. So we still could calculate what we have per square meter. That is, of course, we can do that, but there is a better way to compare these two. There is a better way. I think a lot of you already know what we can do that is more useful in order to compare any type of system. Now because we are not cultivating on an arrow, and we cultivate on arrows and we can multiply them, but we cultivate simply in space, you know. We cultivate in a certain space. If that has a height, let's say we have, for example, 40, 40, and 40, and that here in between. So 3 times 40 is 12, 120, plus these two, it could be 15, and then that makes plus 30, makes 150 centimeters. All these numbers are just random. So that would be 150. Okay. And we said this is 1. So this is 100. And this is also 100. So we have 100 and 100. So I think what we can say, we have 1.5 cubic meters. Okay, so what we get is kilogram per cubic meter. because this is a lot more useful than adding up all our errors, simply because it includes the total room we are using. Okay, so the first approach, it was not wrong, and of course you can always calculate that in addition, but you know, every system, it has a certain requirement of space, and we should put the yield in relation to that amount of space we use, because then we can compare any system. Okay, because consider the following: a system can be in a way very efficient, but you can waste a lot of space, because if you waste, for example, here in these two, if you for example say we want to use a system where we spray the roots, and then we take, for example, here because we want them to hang free, and then we use 50 centimeters or so. When you scale this up to 100 layers, then you see you will lose room efficiency. Okay, so this is the formula we should use, and no matter how you build a system, no matter if you have single layers or if you have circulating tubes or whatever, you can always apply this formula. Always. Okay, let's go back to this example for a moment. You see, we have on this picture, we have 4 of these tubes, okay? And of course, you could put these tubes into a certain space. And what you can see is there is a lot of space in between. And that is the point. The point is that if you have an alternative system, I will show this on a new slide on our board. Okay, let's draw this on a new blank board. So we had these tubes. I'm sorry when they overlap a little bit. I know this is horrible, but I think the point is clear. You can clearly see that you have gaps here. I mean, one could argue like, why don't you arrange them like this? And you fill the space better. Yeah, it's not a bad idea, but look, the gaps get smaller, but on the sides you have gaps again. But it's not about the tubes in particular. They're also like systems that have columns, you know, and where the plants are on the sides, and sometimes the columns they rotate like this. I think you know what system I'm talking about, and it does not matter, because you also could put that in a certain space, of course, you know. So the message is there is always a certain space in what we cultivate, and there is always a yield that we can measure. And that is the only way we can compare, for example, we could compare, for example, these two systems. One system that has circulating tubes, and one system that has these columns. No matter whether something is moving or not, we have here in that case a certain yield per square meter, and we have that here. I think I will show that on the next slide. Okay, let's say this is our system here. The arrow shows that it is circulating. We have a central LED, and we have here in that example, we have a couple of plants around the central LED that is circulating. And of course, every system we've just learned that requires a certain space. But what I'm trying to open your mind for is just imagine one of these plants. Imagine that is one of these plants, okay? And it does not matter. Let's imagine one plant is in a normal, regular vertical farming system where one plant is cultivated right next to the other, okay? Of course, these plants, they also require a certain space, you know, all of them. And let's say they are supposed to grow all equal. They all require a certain space, all the same space. And let's say this was, for example, let's say it was 3 liters, which is 0.000.003 cubic meters. And here it comes. It does not matter in what position that plant is. It does not matter, because let's say when you have a lettuce plant and when you have a space of 3 liters, a lettuce plant that has around 200 grams, for example, or more, fit in 3 liters. And it doesn't matter in what angle that plant is. It does absolutely not matter. So what I'm trying to explain is when people build alternative systems, what they are doing is they rearrange or relocate plants in a space. Because that's basically what they are doing. It doesn't matter whether they move or not. We come to that later. We will cover the movement of the plants. But first, imagine the following: that no matter how if you have a lettuce plant that has 200 grams or 250 grams, that requires 3 liters no matter in what position it is. Imagine any object, no matter how you move it, the volume of the object it requires in space, it does not change, okay? And I would like to add something that was on the opening slide. There it said, are these systems scam? Well, I would not say that they are scam, but when people build these alternative systems and they say they yield better, well, then you need to be able to analyze how good they yield in relation or in comparison to other systems. And scamming means that your intention is to fool someone, to sell someone something that is not really good, or even maybe harmful. But in that case, I think a lot of these producers of these systems, they're not really aware of what they are doing, and that's the first thing. And the second thing is, it is a market, and in a market you may participate, and if you convince people to buy your product and they are going to buy it, then it's fine. But in my opinion, these systems should be compared to each other in a way that they can be compared to each other with one formula that suits for every system, and that is that one that I've shown on the recent slides. Now let's make a small summary of what we have just seen. So we can apply the kilogram per cubic meter in every system, no matter whether this is a regular shelf-like built vertical farming system. We could extend that formula to kilogram by cubic meters times joule or energy, because consider that you require additional energy for circulating your plants in that systems we have been talking about. And always remember, we just rearrange the plants in space. Nothing more than rearranging the plants in space. Okay, guys, I would also like to stop here for that moment because the video is already longer than 25 minutes, and I will make a second part of that series. And in that second part, we want to take a deeper dive into what kind of experiment could one do in order to compare a regular system and an alternative system including movement, in order to find out whether in general that movement that is included in a lot of systems, whether this is useful or not. Thank you for watching. Like the video, subscribe, and leave a comment if you want. Bye bye.